بسم الله الرحمن الرحيم والصلاة والسلام على أفضل الخلق محمد وعلى آله الطيبين الطاهرين. My thesis today is improving energy consumption in IoT networks, reducing sensors energy by timing control. Supervisor Dr. Muhammad Rashid, student Ali Hameed Luaibi Al-Ta'i, 2022. Introduction. The number of sensors is constantly increasing dramatically as a result of the urgent need for them in homes, factories, hospitals, militaries, facilities, etc. And consequently, a lot of energy consumption increases, and due to their continuous work without stopping, it became necessary to think and study to reduce energy consumption. Our work in this research referred to reducing its energy consumption by making a schedule to set a timing for the sensors to work and stop according to the user's request and under his control. We proposed several scenarios for different on-off operating time. From the results, the proposed mechanism scored higher operating time when the off period is higher, 120 hours successful lifetime. However, even with a longer working period, we managed to obtain at least 20 hours of operating time. The objectives. The following are the objectives of the research. 1. Doing an extensive study on the ideas and the studies presented in the process of reducing the energy of the sensors, and coming up with the best results compared to this study. Working to reduce the energy of the sensors by sleeping and waking up in scheduled way according to times determined by the beneficiary, according to his request, and according to the type of situation in which the sensor is used. 3. Extending the life of the energy sources used in the electronic circuits in which the sensors are used to take advantage of the increased power time of the electronic circuit. 4. Increasing the efficiency of the work of sensors and devices used in electronic circuits, resulting from reducing their working times. 5. High accuracy in performance due to reducing confusion in the process of the collecting information for reading the case. 6. Preserve public, private, and even human properties by avoiding any danger in home, medical, military, and industrial facilities. Internet of Things, IoT. The Internet of Things, IoT, is a network and service architecture connected and capable of self-configuring. It's built on open standard protocols. The Internet of Things is made up of heterogeneous objects with identities, physical characteristics, and digital characteristics that are safely and seamlessly connected to the Internet. The IoT seeks to enable connection between objects at any time, anywhere, with anything and anybody, preferably utilizing any network. IoT enabled the connection of billions of objects to the Internet and gave rise to a wide range of applications that affect every aspect of human life, including connecting cars, wearables, health monitoring, military applications for intrusion detection. What IoT devices? Numerous networks that enable device communication via the Internet make up the Internet of Things. These gadgets are frequently referred to as things, and each of them has a unique set of characteristics identification. The first characteristics of IoT devices is this. Within the network, every IoT device has to be individually recognized. Two techniques, IPv4 and IPv6, are used to provide network objects with sensitive addresses. As more items have been added, IPv6 128-bit addressing method has replaced IPv4 as the primary addressing protocol. Sensing. Data collected from the physical world is referred to as sensing. Data from devices is collected using a variety of sensing tools, including smart sensors, actuators, and radio frequency identification tags. Communication. Through linked devices, the process initial sending and receiving data, messages, files, etc. to communicate amongst things. Systems link Bluetooth, wireless networks, RFID, and others are employed. Computation. The data collected from IT devices require computation. Additionally, excess or unnecessary data is removed using the technique. To do computations on the gathered data, a variety of hardware and software platforms are available. Services. Services are those device features that are made available to users based on the information they receive. Semantics. It's the very last characteristics of IoT devices. It speaks to the capacity of IoT devices to gather accurate data from their physical surroundings and present that data as a service at the right moment or as needed. According to their primary requirements, there are three sorts of IoT applications. 1. Applications that run in real time and have deadlines. For instance, real-time monitoring of vital signs is necessary for connected health and smart farming, and the smart supply chain requires real time for effective trade. 2. Data analysis applications, which are designed to analyze the data to maximize commerce, cities, and electrical grids, respectively. Smart retail, smart city, and smart grid use data analysis. 3. Device interaction applications emphasize relationships between devices. Device interaction is a primary goal of smart homes, wearable, and industrial internet. Hardware design. Hardware design refers to a collection of tools or design used to construct prototypes of smoke detection and neutralization based on IoT notification using an Arduino MQ2 sensor and microcontroller. 1. MQ2 sensor. MQ2 is an electrical component that detects hydrocarbon gas levels like smoke. This sensor has high sensitivity and a short response time. The output of this sensor is in the form of an analog signal, and it requires a 5-volt DC supply to operate. 2. The rechargeable batteries, lithium-ion. They are the greatest ever, with a voltage of 3.7 volts and current of up to 4,000 milliampere. And certain varieties have a life duration of up to 5 years. It's the first and most appropriate solution of Arduino circuit feeding. It has a great discharge property that allows its function with heavy loads. 3. MCU Ono. It's a microcontroller board based on the ATmega328P. On the board, there are 14 digital input-output pins, 6 of which are PWM outputs, 6 analog inputs, a 16 megahertz ceramic resonator, a USB connection, a power connector, and the ICSP header, and the reset button. It includes everything you'll need to get started with the microcontroller. Simply connect it to a computer through USB or use an AC to DC converter or battery to power it. Although it supports voltage between 7 and 20 volts, it may be powered by a 9-volt battery or a USB connection. 4. Relay board. In this project, the relay model is also used to provide connectivity between 2 or more locations in response to an input signal. It's connected to the fan as well as the bulb that act as the output. Relays are used in a wide range of applications due to their relative simplicity, long life, and proven high reliability. The goal is to keep power safe, regulated, and under control. 5. Circuit with an Arduino microcontroller, a buzzer, and DC fan. Based on IoT notification and an MQ2 sensor, they depict the series of smoke detection and neutralization procedures. One of the processes in system development is implementation, which is the process of putting a smoke detection and neutralization system on campus and making it operational. It might be regarded as an attempt to bring the bullet system to life. The purposed system design. The Arduino IDE, Integrated Development Environment, an open source platform used to create and upload computer code to the physical board, is utilized to program the microcontroller in our suggested system. The system was constructed utilizing 2 separate pieces of software, an easier to learn and easier to program variant of C++ is used by the Arduino IDE. Integrated Design Environment IDE for Arduino may be downloaded from this page, any version, arduino.cc en main software. The Remote XY platform, a free cloud-based tool for creating mobile applications for devices that support Android, was used to construct the Android mobile application. On the website remotexy.com, there is an editor for mobile graphical controller board interfaces. Software design. Connecting the controller and using a graphical interface to control, it's possible with the help of the mobile software Remote XY. Using a cloud server to connect, we can control the gadgets using Remote XY from any location with internet access to connect to a Wi-Fi access point. The ESP8266 model will be set up as a client. An internet connection is required for the access point. The device will be registered on the cloud server to the Remote XY library. Instead of directly communication with the device, the mobile application will be linked to the cloud server. As a result, anybody can access the gadgets through the internet from anywhere. System architecture. Our purpose architecture considers sensors node connected to gateway Arduino. The sensors are randomly distributed among the gateways. The gateways are connected through a server as shown in the figure. Sensors node generate a set of tasks and send them to the gateway, which then send them to the central server for processing. Gateways can do some processing as well, generate and filter the data, and the MCU will take action based on the collected data and send it to the server. Energy consumption. Each node in the IoT network is considered to be an active computing node. The energy consumption at a node is determined by the processing load inside the CPU and the memory. This is a standard for these types of network. Let Ni be the ith active node. The energy consumption E for I is given by E equal Nij multiply N dash active multiply Ki, where Nij is the number of needed iteration to execute at node I, and dash active is the number of times node I was active, and K for I is constant, representing the extra heating produced by the CPU. The total energy is given by E total equal to sigma I to N, I equal 1 to N, multiply EI, equal sigma I equal 1 to N, sigma I equal 1 to M, Nij multiply N dash active multiply Ki, where M is the number of iteration needed for each node I and N in the total number of IoT devices in the network. 3. Sleeping scheduling algorithm. Every node can enter a sleep status based on decision made by the gateway. Having the gateways calculate the sleeping status for the node will reduce the unnecessary energy loss from sending information to the server. For a node that enters sleeping status, the gateway needs to calculate. The gateway will assign certain sleeping period for the node based on the number of active nodes adjacent to it and based on the frequency this node sends change reading. A node sends different change reading over a time period T for I and will be given short sleeping intervals, while a node with no major change in the readings or has active neighbors STH greater than half of the total number of nodes connected to the same gateway will be given longer sleeping intervals. Algorithm 1. Sleeping algorithm. Input adjacency matrix and a set of nodes as Jaccard similarity index from algorithm 2. Output nodes ready status to enter sleeping. Steps begin. Gateway transmits a hello packet to calculate the number of connected nodes. 2. Rat table for each node I. Record reading V. 3. For each node I belong to N. 4. Calculate the Jaccard similarity index as for Ij. For I using algorithm 2. Reading is not changed. Node has enough wake nodes. 5. If delta R equals 0 and max S for Ij greater or equal STH. For all I belong to Ni. 6. Assign sleeping interval 30 to 50. And if else, find active neighbors with max Sij greater or equal STH. And if and for loop end. Algorithm 2. Jaccard similarity index. Input AM. Adjacency matrix. D. Distance between nodes pairs. TR. Transmission range of the sensor's node. Output S. Similarity index for every node pairs. Steps begin. Adjacency matrix AM for Ij equal 1 if D less or equal TR, 0 otherwise. D is the Euclidean distance between two nodes. 2. For each node I belong to N dash N base. 3. Find real neighbors for node I are V for I equal I AMI j equal 1. 4. Node I will share the list of real neighbors including all nodes, V for I. 5. Find Jacquard similarity index, S for I, j equal to absolute V for I, intersect V for j, over V for I, union V for j, absolute, and end of loop return as end. Here we have table 3.1, the results of comparing the status of the timing control with the reference 9.2. Simulation round, approach 2 without sleeping, compared to protocol, approach 1 with sleeping. Figure 3.8, showing the calculation chart of the working time with the status of the timing controls scenarios, with the working time for the global mechanism in 92 is higher than the local mechanism. The purpose mechanism's working time in the best when the operating time is the smallest. However, even when the operating time is the longest, our purpose mechanism operates longer than both the compared local and the global. The purpose of the research. In general, the work of sensors is constantly increasing, and this in itself is a bigger problem in energy consumption, which we urgently need, as well as the problem of the continuous work, which reduces its consumption life, and we urgently need to reduce energy consumption and increase its working life to reduce costs in general in terms of energy consumption, increasing its consumer life. And in-depth studies today aim in all ways to increase and develop modern technologies in developing the reality of the human and the technological need for the benefit of the consumer to increase accuracy in work and reduce time and efforts. Among the challenges in the field of energy reduction is the urgent need for sensors, so our research works to reduce the energy of gas leakage sensors, temperature rise sensors, and other sensors that are not instantaneous, such as motion sensors and others that need instantaneous sensing. Conclusions. In this work, we used a very efficient and recent method of energy consumption, where our work depends on the timing of the sensors to work and sleep in seconds specified by the user through programming the Arduino through its own program in the C++ language. That the Arduino chip works on by charging the sensors work from continuous work to working at times chosen by the user, programming it to work in seconds and sleep in other seconds, and we got excellent results to increase the processing time of the double battery power. And thus we have obtained a great benefit from reducing power and saving a lot of efforts and extending the life of the battery and all components of the circuit to keep it working. Acknowledgements. My thanks and appreciation to Supervisor Dr. Mahmoud Rashti, Advisor Dr. Nadia Ali Qasim, all committee members, many thanks.